everybody, welcome back to our YouTube channel. In today's video, I am going to show today's Leetcode problem. Today's Leetcode problem is 556 Subarray sum element k. Okay, sum equals k. So let's try to read the problem statement, and after that we will see the approach that how to solve this problem. So we have given an array of integer nums. We have given one array and an integer k. Okay, return the total number of continuous subarray whose sum is equal to k. Basically, in the problem statement, we have given one integer array, okay, and also an integer k, and we have to return the total number of contiguous subarray such that the sum of those elements is equal to k. Suppose if I see this example, that then we have given an array and all the element in array is equal. So we have also given an integer k, and we have to find that how many subarray exist in this array such that the sum of that subarray is equal to 2. If I see these two elements, then this 2 gives the sum is equal to 2, and also if I consider this two element as a subarray, then also give the sum is equal to k. So we have to return the 2. If I consider these cases, then we have to find k is equal to 3. Okay, k is equal to 3. So we have to find the subarray whose sum is equal to 3. So the one subarray is this one 1 2, that gives the sum is equal to 3, and another subarray is equal to 3. Subarray is basically the contiguous element. Subarray means always be considered that element in contiguous form, not in the random, like if I consider 1 then 1. No, always consider the contiguous. So I hope you all understand the problem statement. So let's try to see the approach of solving this problem. So if in the problem statement it is given that we have to find the subarray related thing, then one basic approach is like that: generate all possible subarray. Okay, all possible subarray. So for generating all possible subarray, we need two for loop, one loop and another. So for this is the brute force approach, that to generate all possible subarray and check which subarray gives the result is equal to 2, then increase the count plus plus, and if not, then we leave that thing. So this is the basic approach. So in this problem, if I try run the basic approach, that then how looks like, see here n is equal to 3. So first run a loop from I is equal to 0 to 2. Okay, 0 to 2, and after that for each I find the all possible subarray. So we have to find the sum. So first take the sum as array of 0, and after that again a loop from j is equal to I plus 1 say 2, and after that we find increase the sum as array of j, and after that whenever we hit the sum is equal to k, then we have to increase the count plus plus. Okay, if I try to submit this approach, then you will get the time limit exist error. So let's see the code of this approach. I have written the code in the comment section. Let's see. This is the code of brute force approach. So first we have to find the size of the nums array, and after that we take a count variable that gives the count of the how many subarray exist, that gives the sum is equal to k. So as I have discussed that we have to take two loop. One loop is start from 0 to n. Suppose if I consider this thing, so 1 2 3 and k is equal to 3. The first loop is start with I is equal to 0 at this position till we go to n. Okay, n minus 1. For every I, first calculate the sum. So here sum is equal to 1. Okay, sum is equal to 1. See, sum is equal to 1 till here, and after that we execute this for loop. So this for loop is a start from I plus 1 to n. Then check whether the sum is equal to k. Here sum is equal to 1, but we need the sum is equal to 3. So no. So this loop will be not executed. Then increase the sum is equal to sum plus j. Now sum is equal to 3. again this check happens. If sum is equal to k, yeah, this is correct, then count is increased by 1. Okay, and after that again add the sum. So again j is equal to 3, so increase the sum is equal to 6. Then this loop will be end for I is equal to 0. Again this happens for I is equal to 1. Okay, this happens for I is equal to 1. So if I do for I is equal to 1, then j start from here. Okay, so first sum is equal to 2, and after doing this iteration, after doing this loop, the sum will increase to 3, that is 5. So we are not getting the sum is equal to 3. So if I do the iteration for this thing, that is I is equal to 2, so first sum start with 3. See, if I is equal to 3, then first sum will be nums of I. So nums of I is equal to nums of 2, so sum will be become 3, and after that this loop will not be executed because they start from I plus 1. So I plus 1 go out of the bond. So we have to check that things here after this loop, because if you are not doing this statement, then we are not gonna get the sum that gives from the one digit. Okay, so if I take the at this position, then the count should be increased by 1, then again count is increased by 2, so we get the count is equal to 2, so we have to return the count is equal to 2 at this position. I hope this brute approach you should understand. So let's try to optimize this, because if you try to submit this approach, then you will get the TLE error. So let's try to optimize the code and see whether optimization possible or not. So see, in the optimization part, what I will do that we take an unordered map. Unordered map, what unordered map do? Unordered map contains key and key value pair. Okay, so in the key we take the sum part, and value pair a count of the that sum part. Suppose if I consider these things, then in the map we start putting the sum. Initially the sum is equal to 0 and count is equal to 1, and after that we check the contiguous, we increase the sum in the contiguous form. So if I iterate this thing, so sum is equal to 1, so take the sum is equal to 1 and increase the count is also 1. If I consider these two part, then sum is equal to 3 and also count is equal to 1, and if I consider this whole part, then sum is equal to 6 and also count is equal to 1. So see, at every point we check whether the current sum minus k exists in the array or not. So suppose if I am at this position, so our current sum is equal to 3, so we have to check whether 3 minus 0 is exist, sorry, here k is equal to 3, so we have to check 3 minus 3 whether exist in the map or not. If exists, then increase that how many times that occur. So if I consider here, so I consider this position, the current sum is equal to 3, so check 3 minus 3 exists in the map or not. So yeah, this exists, so it means that we get one sum that gives the value is equal to sum, because suppose there are some other element lie at this side, so this element we have gives the sum is equal to 0, and we get another element that gives the sum is equal to 3, so this portion gives the 3 minus 0 sum. So we get the subarray that gives the sum is equal to 3. So we have to increase the count is equal to how many times 0 occurs. So count is increased by 1. Okay, and if I consider this whole section, then our current sum is equal to 6. If 6 occur, then we have to check whether 6 minus k is equal to 3. So we get 3, whether 3 is exist in the map or not. So see, this 3 exists in the map. It means that we get another subarray that gives the sum is equal to 3. See, this whole portion gives the sum is equal to 6, but if I consider this portion we get sum is equal to 3, it means that this portion gives the sum is equal to 6 minus 3, that is 6. So we have to increase the how many times 3 occur. So we have to increase again count by 1. So now count is equal to 2, so we have to return that count value. So let's try to see the code for the better understanding, and if you are not able to get this algorithm, then try to dry run this code in pen with the help of pen and paper, then you will get the better understanding. So see, in the code section, first I have taken the size of the vector, and after that take an unordered map. So we take the current sum to count the continuous sum, and after that take a count variable. Initially count is equal to 0, then iterate the for loop. First we initialize the map section with 0 because current sum is equal to 0, so 0 have one count. Again increase the count sum is equal to count plus plus I. So if I consider this example 1 2 3, then the current sum will become 1 after we iterate the zeroth part. So this will 1 is also occur one time, and check whether the current sum minus k exists or not. So current sum is equal to 1 and k is equal to 3. So whether minus 2 exists in the map? So no, this is not exist. So we leave this section because we get the zeros from this section. Again we do same thing for I is equal to 2. So current sum will be updated to 3. Current sum is updated to 3. So put it in the map, and after that check whether 3 minus 3, that is 0, exists or not. So yeah, 0 is exist. Increase the count sum by the how many times 0 occur. Okay, so if you do this for n minus 1, then you will get all the count value, and after that you will return the count value. So I hope you all guys understand this problem statement. So let's try to submit the code and see whether it will be submitted or not. So let's try to see the code. So see, it will be submitted for the test case number 1. If you try to submit for all the test cases, then it will be submitted for all the test cases as well. So hope you all understand this problem statement. So thank you for watching the video. See you in the next video.